Bismillahirrahmanirrahim. Can you hear me clear, Shimas?
Yes.
So today we are going to discuss the projectile or projectile motion. First of all, what do you mean by a projectile? Projectile means any thrown object, any object which is thrown. Or like we can throw the ball, right? The arrow is thrown with the help of archery, arc. Bullet is also thrown. You hit someone body with the bullet like a stone, but bullet is far faster. Missile. So they are all example of projectiles, right? So projectile motion is what is it? Consider that we throw an object like that. Suppose we throw something, a stone, it goes like that. The bullet goes like that. So this is projectile. What is happening when this projectile moves from this position to this position? If you observe, it has moved a bit towards right. It has also moved upwards, right?
Yeah.
Even if you see, we don't need to make. If a projectile, let's say, goes from this position to this position, so it have moved a bit higher and towards right. When it moves there, it has gone a bit higher towards right. And when it moves to this position, now how it has changed, it has moved to this position. As it is going downward, it is also moving towards the right and moving downward. It means the object is moving in two dimensions at a time, horizontal and vertical. And what is making this path to change in a curve like that? We never see the normal objects going like that. It always goes like that out of gravity. The gravity is doing that. So, beta, this two-dimensional motion under the gravity is called as the projectile motion. Right? Clear?
Yeah.
Okay, ji. So, projectile motion, projectiles are the thrown objects, and projectile motion is the two-dimensional motion under gravity. Okay. Now, when we are discussing this, there are 2 points we have to keep in mind that there is no resistive force involved because usually the objects thrown they face the air resistance, right, as a resistive force. But now for bullet missiles especially, they have to go far a distance, and in every kilometer now we can sometime experience more than one changes in direction of wind. So when a missile has to go 100 plus kilometers, it may have hundreds of change in directions of the wind. So sometimes the wind supports its motion, sometimes cancels, sometimes it's sideways coming from the sides. So now it will have complication. So at this level, we are not discussing that much complication. And on the other hand, all these objects now they are usually said to be streamlined. They have the front area streamlined. The balls they not may not have a front narrow area, but still now they are streamlined because the air can slip through their surfaces. So they do act like streamlined objects. Clear?
Yeah.
Okay. So what we have discussed, there will be no resistive forces when we are discussing the projectile. Okay.
Sir, what
Ji.
is resistive?
Resistive means every motion which every force which opposes the motion. Like when you throw a ball on the ground, like football, you hit it and it goes along the ground. Will it keep going for always?
No.
So nothing can stop or move by itself. Always a force is involved to move or stop an object. This is Newton's first law. So why would it stop? The frictional force now. Similarly, when an object is moving in the air with the air, even the football experiences not only the friction from the ground, it also experiences the effect of air, right? The opposing force applied by the air is air resistance, and every force which opposes the motion is a resistive force. It could be the air resistance, the water friction if moving in water, and the normal friction between solid surface, right? We will discuss this in the next chapter, even the chapter next to the next chapter, right?
Yeah.
Okay, so should we move on,
Yeah.
Shabazz? Okay, so beta, the first of all now, actually let me tell you, whatever we will be doing today now, these all are going to be based on these 2 points. If you understand this, the later derivations, they may not be very much required for the exam, but we will do, right? These are the 2 points which are most important for us. I hope we can discuss it, right?
Yeah. Okay.
Okay, what are those? First of all, let us have a look at the basics. Let's say we are having a projectile like that, and we have to throw, so we have to give it a speed. So we throw it with an initial velocity that is u. So we throw this object with an initial velocity u, which is making angle theta with the horizontal. So at this point, it is having two components. I guess we have discussed how to make components.
Yeah.
Component of u along the angle will be u cos theta, and the other component will be u sin theta. So it will keep going. So everywhere it will be usually having two-dimensional motion, the horizontal and vertical, horizontal and vertical, horizontal and vertical, horizontal and vertical, horizontal and vertical. Except at the highest point, for a moment, just for a moment, for the highest position, the velocity for a moment will be almost 100% horizontal. Other than that highest point, everywhere it is doing two-dimensional motion, horizontal and vertical.
In the highest position, there's no vertical.
Yes, because at that position now, the object who has to go like that, at this position, its gradient comes to be zero, right? So it is perfectly horizontal, no vertical motion there. Clear,
Yeah.
Shabazz? Okay. Now, uh, the first point, these 2 points are going to be the most important. After anything after that we do, that will just be based on it, right? What is the point? As we consider, there is no resistive force. When you throw a ball, if it leaves your hand, then do you have any control over it? No, you don't have any control when it leaves your hand, right, Shubham? So,
Yeah.
beta, when we throw something, then there will be no horizontal force acting on the object. Horizontal means x component, the force in the direction of x, not x component. No horizontal force will be acting. It means the horizontal force, the force in the direction of x-axis is zero.
Just when you throw something, like in the beginning.
right throughout the motion. This will apply.
Okay.
You will, when you see the second point, you will understand better. So let us start. So when you throw something, Shamas, do you have any control after it leaves your hand? Or
No.
you, something like cricket, I don't know you remember, know how to play. You hit ball with your bat, it goes higher. And after leaving the bat, we don't have any control over it, right? So
Yeah.
when after it is projected, projectile means projecting, throwing something. So after being projected, after the projection, we do not have any control over self, and there is no horizontal force acting on it, as force is directly proportional to acceleration. Means if one increases, the other increases. If one decreases, and the other same happens. If one is zero, the other is as well zero. It means horizontal, no horizontal force means it is zero, right? So the horizontal acceleration is also zero. So this is the most important point too, which we are looking at. When we say the horizontal acceleration is zero, what does that mean? It means horizontal acceleration is rate of change of velocity, right? What is
Yeah.
acceleration? Rate of change of velocity. Shamas, I want you to write it.
Yeah, I am. I am. It means that the
Acceleration.
velocity is constant. It doesn't change.
Okay, very right.
Unless a force
When the
acts on it.
acceleration is zero, then it means acceleration rate of change of velocity. It means there is no change in velocity. But this is horizontal acceleration. When we say the horizontal acceleration is zero, it means the horizontal velocity. The velocity in x-axis along x-axis stays same. So amazingly, if you see all the blue arrows accidentally, but not accidentally, I had drawn them of equal amount. Can you see?
Yeah.
It's showing the horizontal components
Stays the
stays the
same.
same. And how do you represent it numerically? The horizontal component u means initial velocity. The initial horizontal component or velocity will be same as the horizontal component afterwards at any point. After initial, it will be all final velocity. Horizontal will stay the same, and that is equal to, if initial it is u cos theta, then all the point the horizontal velocities will be equal to u cos theta, right? So
Yeah.
what is the first point? There is no horizontal force acting on it. The horizontal acceleration, there is no horizontal acceleration. This is most important. Numerically, we will be using ax to be zero. And logically, that means when we say acceleration is zero, it means there is no change in horizontal velocity. The initial horizontal component and final horizontal component will be equal. They will be equal to u cos theta, right? And the second, the very much important point, look, what is making the direction to change like that? This path of the projectile, the path it follows like a bowl, a parabola. This path is called the trajectory of projectile. The path followed by a projectile is called a trajectory. And trajectory is of this shape. This bowl like shape, it could be any way, it is called as parabola, right? But the projectile is only of this shape because the gravity always acts downward, makes it change like that. So beta, the path of a projectile is called trajectory, and mathematically, numerically, that is equal to a shape parabolic, and it has somehow equation like that. Maybe you would have done in O level or maths. In Cambridge, our students do this in O level. They draw the
Mhm.
graph of y is equal to x square
Yeah. Yeah. Yeah.
and like this. But the projectile trajectory is downward, so it's with negative x square, right? Clear, beta?
Yeah.
Okay. Let us move on. Now, what we have so far discussed, there is no horizontal force and there is only one vertical force, which is forcing the object to change like that, right? The only force acting on the projectile after we project or throw, that is gravity, and that is a vertical force. Gravity means weight, mg, right?
Mm-hmm.
Only force, mg, weight, gravity is acting, and that is a vertical force. So when we say the horizontal force was zero, the horizontal acceleration was zero as well. But when we
But
say the
yeah,
vertical force is there, so there will be a vertical acceleration and
gravity, which
vertical
is
force is mg and g. Here now one thing we have to discuss, and that is going to be very important. So when the object is going like that, so we can divide it into two parts, when it's rising and then when it's falling. So in all the situation, when it's rising now, you see, when we see the vertical, there is a vertical acceleration. Vertical acceleration means when we say the horizontal acceleration is zero, it means there is no change in horizontal velocity. But when we say vertical acceleration is there, it has y means acceleration in the vertical direction. It means vertical velocity is changing. Have a look at it. When we were drawing, all the horizontal component were same. Can you see?
yeah,
You have to see the focus, the change in vertical component. Can you see? When the object was rising, the horizontal component were getting smaller. And at the highest position, the vertical component was completely zero. At the highest position, vertical component is, can you see how? The direction has become 100% horizontal. Isn't it, Shamas?
yeah,
So this is point. This is going to come in the derivation we are going to do. So beta, when the object is rising, what we observe? The vertical arrows are getting smaller and smaller, and there becomes zero. And when the object is coming downward, you see the vertical arrows are getting. This tells the vertical acceleration speed is increasing when we are coming down. It's increasing, getting larger. Can you see?
yeah,
And when we move against the gravity, it's getting smaller, smaller, and smaller, and becomes zero. Then starts from vertical component to be zero, then starts to getting larger, 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 and that it keeps getting larger. So vertical velocity is not constant and it is changing there. Right, Shmas? So
yeah.
horizontal velocity is not changing, horizontal acceleration is zero, but vertical velocity component of acceleration is there. And that due to gravity, we always take that acceleration to be g. Now, consider this path. When the object is rising, what we discussed, the vertical component is decreasing, getting smaller, and at this position, the vertical component becomes zero. Right, Shmas?
Yes.
Why it is decreasing? Because the gravity was always pulling it downwards. So the gravity is making the movement is going against the movement. The object is rising, the gravity is pulling downward. But when it's coming downward, the downward journey, we have just discussed, the vertical component will be increasing. Why? Here the gravity actually will be supporting the movement in the same direction of the movement. The object is going downward. So when the object is rising or falling, the gravity always is downward. And when we have to show the direction, we use signs positive or negative. So that is why we have used negative sign with both the force and acceleration. They are vector quantities. And why the negative? Because it always stays the gravity, force of gravity, mg weight, and gravitational acceleration. They both are always towards the center of Earth downward, right? So the second and the most important point in the projectile motion, whenever we are going to consider the vertical acceleration, we never use the simple g. We always use g as negative, right? Clear?
Yeah.
Okay. Shamas, is everything clear?
Yes. So,
Okay.
when you throw the object, the vertical component is decreasing, and then when it comes back down, after the halfway point, it's increasing versus still decreasing.
Okay. But for the whole journey, has the g ever changed its direction?
No.
So it is always downward. So beta, in projectile, we always use G with the negative signals, never for with the positive. Because the positive and negative, they are describing the directions. As the direction always stays downwards, so does the sign always remains minus G. Can you keep it in mind? So
Yeah.
whenever we are doing this, we are going to have G with negative sign. Right? So now we said the vertical component is changing. So we know the initial horizontal component as u cos theta, vertical component u sin theta. This is initial. So this is our initial horizontal component. U means initial, and this is our initial vertical component. Right? So we know the initial horizontal and vertical velocity. So what about the vertical velocity at any time? Like we have to find the vertical velocity at that point, at that point, at that point. So for that we need to have the time. So we will use the first equation of motion. If we want to find the vertical velocity at any time, and what we know horizontal velocity stays the same all the time now.
Yeah.
So when we have to find but the vertical velocity is changing, and when we have to find the final velocity, we use this formula. But we want to find the vertical velocity, so we will take the vertical component of all the vectors. Time is a scalar, so we never use x or y direction because x and y are telling the horizontal and vertical directions. Time is scalar, so it always stays the same t, right? So
Yeah.
if we have to find the vertical component at any time after the projecting, the initial vertical component we know is u sine theta. So we will use this formula, and initial vertical component is u sine theta. And I have already mentioned we always take the vertical acceleration to be minus g. Never we take g in projectile. T stays the same. So plus minus will make so its whole formula can be simplified to this. Just plus minus makes it negative. So nothing more mathematical. So this give you vertical component at any time. So beta, a very important formula. Very important formula that will be coming in many a question is this. If it is asked, what will be the velocity at any point? Like it could say, what is the net velocity at this point? So it will be having two horizontal component and a vertical component. If it is asked, what is the velocity at this point? It will be having a horizontal and vertical component as well. So beta, when it is asked the velocity at any specific position, the velocity will be, this will be the formula we have used, seen this formula, and when we were discussing the components we use, like we use the formula, uh, f square is equal to fx square plus fy square, right? That is f square if we take square root. So same formula you get, right? But difference
Yeah.
is the f is replaced by v.
Wait,
So
sir.
this is
Sorry. Wait. What's this for again? The square root
square root is actually the formula was this.
for what? For the vertical component.
Yes, hey, wait a minute.
Okay.
So let's see. These were the components now. The
Mm-hmm.
x component and vertical component. And we are having a right angle triangle. Components are perpendicular to each other. So hypotenuse square is in front of 90-degree angle f is equal to base square plus perpendicular square. It's simple, the Pythagoras theorem, right?
Yeah.
So as when we take square root of both sides, then this 2 is needed to be cancelled by the square root, right? So this is the formula if we had to find a velocity from by using its components. And the same formula we can rewrite it in the form of v. Just replace f by v velocity, right? Shamas, fine.
Yeah.
And I have just discussed this formula with one of my students from the past papers, right? And there is another point. The velocity at any point is sum of the square of horizontal component plus square of vertical component and the square root of the whole sum, right? And when it is asked what could be the angle made by the velocity at any point with horizontal or vertical. If we have to find the angle made by a vector with horizontal x, then we write the horizontal component in the denominator, vertical component in the numerator. If we have to find the angle of a vector with the vertical, then horizontal component will be written up and the vertical component will be written in the denominator. What I want to say is that if a projectile is like that and you are willing to find the velocity at this position, so that velocity we need to know two angles, two components, sorry. What are those components? One the horizontal and the other vertical. It will have a horizontal component and a vertical component. So if we have to, so how do we know? We find these two components. The horizontal stays same from the right. The vertical component changes. We can use V by this formula to find the vertical component, right, Shamas?
Yeah.
And then we can, this remains same, the horizontal, the vertical changes. Then we use this formula, the square root one, this formula to find the value of V. But if it's asked about direction, the angle it makes, the velocity with horizontal is theta x. And the angle the V makes with the vertical, we call it as theta y. So what is the formula for that? For that, if you want to find the tan of angle theta with the x-axis, then x component will be in the denominator. The other will be in the numerator. Similarly, if we want to find the angle with y, then y component will be in the denominator and the other component will be in the numerator. Right? Can you remember, Shamas?
Yeah.
Okay. So now we are going to do four derivations, and with that, it's going to be n of the projectile. These derivations may not be very much required, but now knowing the derivation and when you do it, you have to learn it and write it by heart. The learning of derivation that is very important for your concepts, right?
Mm-hmm.
So we are going to discuss the four diagram. You can easily see the four headings actually, the one, two, three, and the four one. right? Okay, so let's see, move on. So first of all, we are going to have a look at the time of flight. What do you mean by time of flight? Like when you throw a projectile, the time from of its projection till its landing, that is called time of flight, right? Interval between projection and landing of a projectile is called time of flight. Um, like when Pakistan and India were having tension at the borders, they were having chances of wars. So then anchors and different people used to say, we will destroy the whole India in those many minutes, and Indian person will also uh, having the claims to destroy Pakistan in that many minutes. So that minutes actually they were talking about the time of flight of a missile. How much time the missile will take to reach from Lahore or from Pakistan, place of Pakistan to the India. So they were talking about this actually. Time of flight we can represent by capital T or small t, choice is yours. So when we have to find the time of flight means the time between projection and this landing. The time taken from object to start from this and reach this. This time we can represent it smaller t as well. Choice is yours. So what one thing is for sure in this moment, when object is rising and then it falls. Vertically, when it's rising, it vertically goes upward, and when it's falling, it goes downward by the same amount, right? So that means the vertical displacement overall is zero. The horizontal displacement is has some value, but vertical, as it goes higher and goes down by the same amount, so the vertical displacement overall is zero.
Sir, so when it goes down,
We
the
have to
vertical,
find G Shimas.
when it goes down, the vertical displacement zero.
Shimas, can you hear me?
Yeah, I can hear you.
Okay, can you repeat your question, please?
I'm saying like when it goes down, like when it's falling, the vertical component zero.
Actually, yes, vertical component of displacement, not velocity.
Ah, okay.
The velocity component we have already discussed here,
Yeah, vertical component of displacement. And sir, when
right?
you're finding that in a question, if they ask you to find the time, you have to times the time by two because yeah,
Yes,
you have
yes,
to
we will be
yeah.
doing that. Give me a minute,
Okay.
please. Okay. So, Betari, for time, whole this journey, time of flight, one thing sure, the overall vertical displacement will be zero because it has two position rises and falls. So rise may in rise it the vertical displacement is upward, and when falling back downward the vertical displacement is zero. So we use this formula where displacement and time and involve s is equal to ut plus half at square. As we are knowing the vertical displacement, so we will take the displacement the vectors in vertical direction. So all the vector now are written with y here, here, and y here because we are looking at the vector in vertical directions. So all the vectors will be taken in vertical directions. Time is scalar, it is not written in vertical or horizontal direction. So vertical displacement is zero. What is the initial vertical velocity? We discussed it is equal to u sine theta. Vertical initial velocity is u sine theta. Vertical acceleration is minus g. Right, Shmas?
Yeah.
plus minus will make it negative, and the whole half gt squared negative will go to the other side to change its sign to be positive, and then t multiplying will divide and cancel the t square. We can make t with the constant. We make t as subject, sorry. So we get the formula 2u sine theta over g. Is it clear, Shmas?
Yes, let me take a photo.
So you want to take? Yes, keep doing. Take the photo. So beta, this tu sine theta gives you the total time of flight. So it's here u sine theta and g is are multiplied by 2, right? So we can divide the time of flight in two parts. First when it's rising and then it's falling. So 2 times u sine theta, we can say the time it takes to rise is half of that u sine theta, and the same time u sine theta over g it is taking to fall down. And when you add both of them to give you the whole journey for the time for the whole journey, that will be sum of these two values. Right, Shmas? Is it clear?
Yeah,
And the next derivation is maximum height. Maximum height is vertical distance. And one thing we know, at highest point, the vertical velocity is zero. We discussed it many a times. One thing for sure, at vertical velocity, it almost is same. Okay. So I'm going to repeat it. At vertical, at the highest position, the vertical velocity is zero. So we have to find that vertical distance. We are now going to find this maximum horizontal distance. Vertical height we have to find. Vertical height is a distance. Now we use third equation of motion. And Shamas, I told you in projectile we always take the acceleration to be minus g. The vertical acceleration is always minus g, and the vertical distance or displacement we have to move is vertical acceleration is minus g, and that vertical distance is h. Vertical component at highest position is 0, and initial vertical component is u sine theta.
yeah.
Here you can see this u sine theta, and the final vertical component for reaching is 0. So what we have done, so beta g vertical component at highest position is 0, we place it, acceleration is minus g, and initial vertical component is u sine theta, and square root of it will give you u square sine square theta. We have to find the h.
We just have to move two minuses to the other side, so it divides because it's getting times.
Okay, so we make h to be the
Yeah,
subject and
subject.
we get this formula, right? Okay. Now, Shamas, the next is range. This is very important. When we talk about the weapon power, weaponry power of a military, then it is hardly, it is very uh, importantly depending upon the range of its missiles, right? What do you mean by the range is the maximum horizontal distance covered by the projectile means the from the point of its projection to the range is the maximum horizontal distance from the point of projection to the point of landing, and this distance, the horizontal distance, is said to be the range. This one, right? Shimas,
Yeah.
we have mentioned it here. So this is said to be the range. So range is the horizontal distance, na Shamas. So
Yes.
we use S is equal to UT plus RV square in the horizontal direction. Means we are writing X with all the vectors. Whenever we use an equation in a particular direction, then we have to consider all the vectors in the same. When we were taking vertical, we were taking all the vertical vectors component of all the quantities. And when we are considering the horizontal distance, then the whole equation is having the vectors in the horizontal or x direction, right? Clear?
Clear.
As we started with this, the horizontal acceleration is always zero in projectile. So ax is zero, and that if you substitute zero here, this whole is going to be zero, right?
Mm-hmm.
So we are left with this, the horizontal distance, which is called the range. So horizontal acceleration is zero. This all becomes zero. Horizontal distance is called the range. Horizontal velocity is u cos theta, right? We have seen right from the start. The horizontal component is u cos theta. But importantly, the horizontal component is u cos theta, and time is for range means time from starting projection to the landing. And that time, isn't it called the time of flight,
Yeah.
which we calculated here? This one. So beta, we substitute that time here, 2u sin theta over g. Now u multiplying with u gives you u square. U times u square. Cos theta 2 and sin theta we can write them as it is. And g is in the denominator, it comes to be the same. So beta 2 sin theta and cos theta. If have you done the trigonometry in math?
Yeah.
Do you know this is a formula? Double angle identity. 2 times sine theta cos theta is equal to sine of 2 theta. This 2 is multiplied with angle, right? Clear, Shamas?
Yeah.
Okay. Beta, these are the formulas now. It's not necessary do you remember these, but you should know how they are driven, how they were derived, right?
Yeah.
Okay. Shamas, now we are going to look at the last one. And what is that? And the most important one. Sometime now, usually we were looking that a projectile was starting from a horizontal position and then it was landing back to the same position, like it goes. But sometimes now, rather than throwing the object, starting the object from the horizontal, we throw the object from a highest position. What do you think? Will it keep going horizontal? No. The gravity changed the path like that. So as you can see the example number 4. So beta ji, this is going to be important. Consider we throw an object from a highest point. The height we represent as y. Sorry again for x and y. When we throw an object in this direction, at the starting, well, let's say its velocity is u. That is 100% horizontal, right, Shimas?
Yeah.
It is 100% horizontal. So initial vertical component is zero. But when it keeps going, it is going forward and is getting lower vertically. So it is again covering two type of direction, two dimensional motion. One is vertically downward and the other is horizontally forward, right? So when we throw, it will hit at a point which will be a bit on difference of horizontally distance it would have covered. We call that distance as to be x, and it has now vertically changed its position from this level to this level, and we call that vertical displacement to be y. So when the object is thrown from its point of projection to the point of landing, it has moved by this much horizontally and by this much vertically. So the vertical distance covered by this projectile, the horizontal distance is said to be x and the vertical distance is said to be y. We are going to drive the formula for both of them. And we will drive the formula, but later on, we have to use the formulas directly. These will be very important. So what is that? The horizontal distance is x, vertical distance is y. So we use the second equation of motion s is equal to ut plus half at square, both horizontal directions and vertical direction. And when we apply one vector in the horizontal directions, all the vectors will be in the horizontal direction as well. If one component is vertical in vertical direction, the other components are also in vertical direction. Right, Shamas?
Yeah.
Okay. As we know, in projectile motion, the horizontal acceleration always stays the zero. So beta, when we use zero here, all this value is going to vanish. Then we will be left with ux times c. So as the initial velocity was exactly a horizontal velocity, so we substitute the horizontal velocity ux by simply u. So beta, this is the formula you should know, the derivation of horizontal covered by an object. Right, beta Deep? This is the
Yeah.
formula you should learn for horizontal distance. And again, so when the object moves from this point, let's say A to this point B, it covers a vertical distance downward as. So for downward, we will use again the formula S is equal to ut plus half at square. In vertical direction, the vertical component, initial component will be zero because initially the movement was purely horizontal. So the horizontal velocity will be zero. Sorry, vertical. Movement is purely horizontal. So vertical part of the movement will be zero initial. So making that zero will make all this part go vanish. We will be left acceleration. I have already told we use vertical acceleration with minus g, minus sign. The acceleration will be g with the minus sign. The minus will be cancelled, and this will be the formula for vertical
So for
distance.
horizontal, it's ut, and for vertical, it's 1 over 2 gt squared.
You have to remember. And whenever we are to ask what is the displacement between A and D, can you see this will make a right angle triangle? Then using Pythagoras theorem, we can find the value of AB, the square of horizontal distance plus square of vertical distance and square root of that. That can be a replica of this one, right? That was in terms of velocities, and this one is in terms of the distances. Right, Shmas?
Yeah.
Okay, Shmas. Now,